Today we're going to continue solving one-step equations, and the equations that you guys have seen in the past, you've just needed to use addition or subtraction to get your variable by itself. Addition is the inverse operation of subtraction. Today we're going to be solving one-step equations that will require you to use multiplication or division as your inverse operation. Okay, before we start looking at equations, let me just point out, once you start using algebra or using variables in your math, you really try to avoid using the times symbol. Okay, the times symbol is more used for elementary level classes and no longer used in algebra, and here's why. Let's say I was writing the problem 3 times x. Doesn't that look kind of funny, having the times symbol and an x right next to each other? This is the reason why the times symbol is no longer used in algebra. It's because it looks too much like an x. A better way to write this problem, now that we're doing algebra, would be to use a multiplication dot. You'll see that used once in a while. To use parentheses, that's another way we could write out 3 times x. Remember, when you have a 3 and a parenthesis, or a number and a parenthesis right next to each other, it does mean multiply. And probably the most common way you'll see this problem written in algebra is just simply 3x. A number and a variable side by side does mean multiply. Okay, technically there is an invisible multiplication sign in between those. So this literally means take 3 times whatever x is. Let's say that x equals 2. Okay, so if you were to solve this expression here, plugging in 2 for x, the answer would be 6. Okay, because 3 times 2 is 6. Okay, now you will often see me write problems with the number and the variable side by side, no operation in between. Just know there is an invisible multiplication sign there. All right, so let's look at some examples here. Here we're trying to solve our equation for x. And let me first draw my wall here. See if I cover up this -3 in front of the x. X is all by itself, isolated on the left side of the wall, which is what I want. How do I get rid of that -3? Well, remember, the main operation in between the -3 and the x, there is multiplication in between there. It's just invisible. So to get rid of this -3 up front, I need to do the inverse of multiplying, or I guess reverse multiplication with division. Okay, so I'm going to divide by -3 on the left, also divide by -3 on the right. A -3 divided by a -3, those cancel each other out, and I'm left with x all alone on the left side of my wall equals, how many times does -3 go into 45? Well, remember, opposite signs, negative answer. I know my answer will be negative. And then I just do a quick division problem to figure that out. And I get a -15. Okay, so in this case, we did have to use division to get x by itself. Now, the most common mistake I see students make with this problem is this. students see the -3 and think, oh, I need addition. Okay, the main operation in between the -3 and the x is not addition. The main operation between the -3 and the x is multiplication. This would be the wrong inverse operation, and this would get you the incorrect answer. Okay, so just because you see a negative there does not mean you need addition. You have to remember there is a invisible multiplication sign in between the -3 and the x. An example problem where you would use addition would be x minus 3 equals 45. In this case, you would need to add 3 to both sides to get x by itself. Okay, so you can clearly see the difference between this problem at top and this problem here on the left. On the left, we need division as our inverse operation, and on the top, we would need addition as our inverse operation. Let's look at a second example. X divided by 2 equals 50. Draw my wall. Now, if I cover up this division by 2, x is all by itself on the left side of the wall. How do I get rid of division by 2? Well, I do the opposite of dividing by 2, and I multiply by 2 on both sides of my wall. Now here's what's happening. Technically 2 is the same thing as 2 over 1. And these two 2's are going to cross cancel each other out. And now on the left side of my wall, I have just x isolated equals 50 times 2 is 100. Okay, in the bottom example here, -2a equals 5. Draw my wall. Okay, now if I cover up this -2 up front, a is all by itself. I need to get rid of that number. Now remember, the main operation between the -2 and the a is multiplication. If I wanted to make the multiplication sign visible, I could write my problem like this. Okay. So the inverse operation I need to get rid of this -2 is division. Divide by -2 on the left, divide by -2 on the right. -2 divided by -2, those cancel, and I'm left with a equals -5/2, or I can write my answer as a mixed number, -2.5. Okay, so today pretty much all the equations that you face, you will need to use either division or multiplication to get your unknown variable by itself. We're going to end with just a couple more examples. This one is actually very simple, but seems to throw students off a lot. -b equals 4. Draw my wall. Now, if I cover up this negative sign, b is all by itself, like I want. Now, how do I get rid of a negative? Technically, there's an invisible 1 behind that negative. Okay, and my problem is technically a -1 times b. The 1 has just been made invisible. So how do I get rid of this -1? Well, remember, the main operation between the negative and the b is multiplication. It's just invisible. So to get rid of the -1, I use division. Divide by -1 on the left, divide by -1 on the right. A -1 divided by -1, negative divided by negative is positive. So those cancel each other out and we're left with a positive b equals 4 divided by -1 is -4. Opposite signs, negative answer. Okay, now if we plug our answer back in to see if it works, my original problem had a negative in it and my answer also has a negative, creating a double negative. Does double -4 equal 4? Well, we learned that double negatives should always be rewritten as plus signs. So does +4 equal +4? Yes. Okay, my last example here. Draw my wall. S divided by -4 equals -3. Now, if I cover up this division by -4, S is all by itself like I want. How do I get rid of division by a -4? Well, I need to do the opposite of division, which is multiplication. So I'm going to multiply by -4 on the left and multiply by -4 on the right. Remember, this is technically a -4 over 1. And these negatives and these 4s will cross cancel each other out. Now S is all by itself on the left side of the wall. And a -3 times a -4 is a +12. Same signs, positive answer. Again, on your homework, some of these problems may be mental math for you guys, but I do want to see your inverse work. Very soon you guys will be facing equations that are literally impossible to solve just using mental math. You need to know how to use the inverse property to isolate your variable. So make sure you show your inverse work.